All right, guys, so today we're going to be working on rate of change and slope notes. So first thing we need to know that rate of change is going to be talking about the change in the dependent variable over the change of the independent variable. And that should be slightly familiar from science class when you talk about science experiments. So the table shows the distance a band marches over time in the St. Patrick's Day parade. Is the rate of change in distance with respect to time constant? What does the rate of change represent? So let's first go. We want to see how far did they march in the first minute. So time and distance. So the dependent variable, the one that's depending on the other, is how far they marched. So if we say 520 minus 260, so that's the dependent variable, over independent variable is going to be 2 minus 1. Those were the minutes, right? The second minute to the first minute, or first to the second minute. This is equal to 260 over 1. Now let's look at from minute 2 to minute 3 the change. So we'd have 780 minus 520 over 3 minus 2. So that's going to equal 260 over 1. And then the third one, from minute 3 to minute 4, is going to be 1040 minus 780 over 4 minus 3. Just want to double check that it was recording. So, is the rate of change constant? Yes. What does it mean? This means that they marched 260 feet per minute. So now let's talk more about slope. So slope, like why did we do this? Slope is what we call a constant rate of change. The symbol for slope is going to be m. And when we look at slope, it's always the vertical change over the horizontal change. Also, more commonly known as rise over run. So that's if you're just looking at a graph. You just have to count. Now, if you were given points on a graph and you want to know the slope of the line between the 2 points, it's going to be y2 minus y1 over x2 minus x1. There are 4 different types of slope. If we are going up from left to right, it is going to be a positive slope. So m equals positive. If our slope is going down from left to right, our slope is going to be negative. If we have a horizontal line, our slope is going to be 0. And if we have a vertical line, our slope is going to be undefined. So those are our 4 types of slope. If at any point you guys need to pause this video to write anything down, please feel free to do that. So let's just look at finding the slope when we are given a graph. So all we have to do is count from one point to the next. So I'm starting at this point, and I'm just going to count up. 1, 2, 3, 4. So my rise is 4. 1, 2, 3. My run is 3. So, and my slope is going to be positive because we're going up from left to right. So my slope is just going to be 4 over 3. So again, once you're given a graph, it's all just counting. And I always start from the leftmost point. So I'm going to start at this point, -1, 4. So now I'm just going to count down. 1, 2, 3, 4, 5, 6, 7, 8. So my rise is 8. My run is 1, 2, 3, 4, 5. So my run is 5. So our slope is going to be 8 over 5. And because we're going down from left to right, our slope is going to be -8 over 5. So now let's look at some where we're given 2 points. So first thing I need to do is label my points. So my ordered pairs are always in x, y. And we're just going to label this first one x1, second one y1, and then x2, y2. And again, our formula for finding slope is this y2 minus y1 over x2 minus x1. So I'm just going to set up m equals, that's our slope, y2, -2, minus y1, 0, over x2, 3, minus x1, -1. -2 minus 0 is -2. 3 minus -1 is 4. -2 over 4, I can simplify. So slope is always in our simplest form. So I can divide both top and bottom by 2. So my slope is just going to be -1 over 2. So if you can simplify that slope, you need to do that. If you don't simplify it and you were going to graph this, you would miss some of the points on the line. So let's look at number 2. Again, I highly recommend labeling all of your points, x1, y1, x2, y2. So I have m equals y2, which is -1, minus y1, which is 3, over x2, which is 4, minus x1, which is 1. -1 minus 3 gives us -4 over 4 minus 1 is 3. So our answer is just going to be -4 over 3. So slope is always a fraction, right? Even if it's a whole number, you can still write that as a fraction as over 1. You never want to turn slope into a decimal or a mixed number. So our answer here is just -4 over 3. Okay, number 3. 4, -3, and 4, 2. So I'm going to set this up again as x1, y1, x2, y2. So m equals 2 minus negative 3 over 4 minus 4. 2 minus negative 3, that just becomes 5. 4 minus 4 is 0. You can never divide anything by 0. So, because of this, your answer, your slope, is just going to be undefined. So if you end up with a 0 in the denominator, your answer is just undefined. And we'll talk more about that when we get into graphing as well. Number 4, we have 3, negative 1, 5, negative 1. So again, I'm just going to label my points, x1, y1, x2, y2. So m equals y2, which is negative 1, minus y1, which is negative 1, over 5 minus 3. Negative 1 minus negative 1 ends up giving us 0. 5 minus 3 is 2. You can divide this. If you have 0 in your numerator, your answer is just going to be 0. So 0 in the numerator, your answer is 0. 0 in the denominator, your answer is undefined. So that is how we are going to find the slope given 2 points. And we're going to do a lot of practice with this as well. All right. Finding the missing coordinate. So if you are given an incomplete ordered pair, so for example, on this one, it has 1, 4, and negative 5 comma r. So you're given 3 out of the 4 coordinates that you need. Our first step is going to put all the given information into the slope formula. So let's just start with that. So we've been setting it up as, just write it up here, m equals y2 minus y1 over x2 minus x1. So m is our slope. Here's our slope, 1 over 3. So we're going to set up as 1 over 3 equals, I'll label my points, x1, y1, x2, y2. So y2 is r minus y1, which is 4, over x2, which is negative 5, minus x1, which is 1. So we put all of our given information into our slope formula. That's step 1. Step 2 says to simplify. So that wants you to simplify this part right here, negative 5 minus 1. So I'm going to keep 1/3 the same, equal to r minus 4 the same, over negative 5 minus 1 is going to give us negative 6. Now our next step is going to be to cross multiply and solve. So we can't forget to distribute, so I'm going to cross multiply. So that means I'm saying 3 times r minus 4, so 3 parentheses r minus 4, because we're multiplying by the whole thing, not just r, is equal to, I multiply 1 times negative 6, so that just gives me negative 6. And now we can just solve from here. So we're going to distribute 3r minus 12 equals negative 6. Add 12 to both sides. We get 3r equals 6. Divide by 3, r equals 2. And there you go. So please email me if you guys have any questions.